Good morning, everyone. Thank you for joining on a Saturday morning. We will wait for 2 more minutes for more attendees to join and then we'll kickstart the session. Your patience is appreciated. Thank you so much. Good morning, everyone, and thank you for joining this exciting tech meetup session on Next Gen Sports. I am Monica, Marketing Manager at Cloud.in, and I would like to take you through the context of the meetup. We are absolutely thrilled to host for the today's session by Cloud.in. And if you look around in today's digital landscape, there is one frontier where the speed of data is matching the physical speed of human achievement in real time, the playing field. Gone are the days when sports analytics meant writing down post-match box scores on a clipboard. Today, sports are a hyper-connected, high-velocity data ecosystem. Every straight an athlete takes, every fraction of a second a ball is in the air, and every tactical shift made by a coach is backed by a real-time telemetry. To take us through the session, we have with us Vedant Sakinal, a solutions architect at Cloud.in. Vedant specializes in designing and secure, scalable, and cloud native architectures that help organizations modernize their IT infrastructure. Along with him, we have with us today Swapnil Vaidya. He is head of cloud consultant at Cloud.in. Swapnil works closely with enterprises to define and execute their cloud strategies that improve performance, resilience, security, and which are cost effective. With extensive experience in cloud consulting, the infrastructure modernization he has helped with numerous organizations. Lastly, but not the least, we have Vivek Gundu, a software developer and AI enthusiast at Cloud.in. He's passionate about emerging technologies. Vivek focuses on building intelligent software solutions that combine modern development practices with the latest advancement in artificial intelligence. Without any further ado, I would like Vedant to take up the session. Thank you, Vedant. The floor is yours. Hello, Vedant. Can you hear us?
Yeah. Uh, let's begin. So, really warm welcome to all of the attendees and the panelists as well. Um, Today, we are going to go over the topic and the webinar that we have configured, which is next gen sports and how AI and analytics are redefining the game. I hope all the attendees might have heard about and the revolution of AI all these years. So from let's say 2022, AI has been booming and it's in integrated to every part of our lives, every sector that we cater to, and every sector that we are into as well. Uh, just before beginning to the webinar and the complete concept of how sports has been dominated by AI, I'll just go over about cloud.in as a company. So we are a 27-year-old organization that has been there from the internet era, which has been excellent in the case of cloud. We cater to different hyperscalers, that is AWS, Azure, GCP, and different cloud providers. Alongside that, we have 100 plus cloud certified professionals, around 4 lakh plus domains that have been managed, and different workloads that we run in production each day. We have a team in Pune. The headquarters are in Pune. The main another company, like another head office, is also in Mumbai, Delhi, Bangalore, and Delaware in the US. So, as Cloud.in is the major premier tier partner for AWS, this is one of the hardest premium tier services that AWS will provide to a partner, through which we cater to different companies, enterprises, SMBs, different clientele as well. And to receive such a status, we do have other AWS competencies that partner alongside us. So, about AI services competency, migration and modernization, SMB competency, as well as education sector, Microsoft workloads, different managed service provider workloads as well, solution providing, public sector, well architected framework. So we do have all these competencies with us as a premier tier partner. It was a long journey from 27 years plus of experience. So yeah, let's begin to our meetup topic that has been discussed a lot, and just wanted to set the stage here. We have hearing about, let's say, sports in general, but have we imagined like how these batters, how these bowlers, how are they so consistent enough? Like how do they analyze each step, each ball they bowl, or not just about cricket, let's say about F1, the leading sports that every Gen Z is talking about, every Gen Z is into, FIFA that has been going on. Each and every step or each and every sport that we look into has some or the other part involved regarding data analysis as well as AI. Why AI and data analytics is much more important, we'll go over throughout the slides. And I do have two of the gentlemen with us. So I'll just introduce myself. So I'm Vedant Sakinal. I am a solutions architect at Cloud.in. I have Swapnil Vaidya with me. He is the solution lead here at Cloud.in. And I have Vivekananda Gundu. He is the software engineering team lead, and he will go over a complete demo regarding how we can implement AI and analytics onto our spot. And you will be really intrigued looking at how we or you can also implement such a implementation on your PCs or on AWS itself. So yeah, just going over how sports in general are working together. So let's imagine a team that is playing against, let's say India is playing against Australia, and each season, or let's say even for IPL, RCB is playing against Mumbai. You have seen particular team members who are sitting besides the ground, who are analyzing each and every ball that has been bowled. One is actually counting down the balls, how it was hit and everything, and even the sensors today, inside the stumps, inside the cameras, who are analyzing each step in the season or throughout the match itself. The tech has been growing so fast that the that it is keeping up to each and every player and their shots that have been played, the bowls have that been bowled. So as you can see on the slide itself, on an ball to ball events analysis, over a million or a billion balls have been analyzed throughout the IPL season, and not throughout the IPL season, of the IPL season as well, or of the ODI series, of the test series that we have been seeing. uh, the bowler as well as the batter as well as the fielder have been analyzed in such a way that the statistics, as you see, let's say on a like win trading cards that you see, the statistics that have been mentioned are throughout the life cycle of the player that we see. So throughout the IPL season, billions of the metrics about each player. Let's say Bumrah, how he bowls to a particular batter. Let's say if Bumrah is facing Virat Kohli, how does he bowl throughout the season, throughout all the matches, throughout the from the start of his career till the last match. And because of this, Virat Kohli, by looking at just the analysis, he knows, okay, what might Bumrah do in the next ball that he's going to play? How can he play him? How can he stop, getting down a wicket and score more for his team itself? So when a captain is actually playing the match itself, he can decide the field, he can decide who will bowl the next over, and how can he get the most out of the bowler itself, getting less runs as well as getting a wicket. So our question was, what if a team could predict a wicket before it ever happens, all through data analysis and all through AI is just a part or implementation which won't be implemented unless you have a lot and a lot of data. When we talk about cricket itself, cricket is a very heavy data analytical sector where each and every player has to be analyzed, has to be gone over certain metrics like how he bowls. Each ball has to be defined, where he bowls. So when you see a pitch, it is differentiated onto different sectors as well. So deep line and then short ball and different kinds of things. And because of it, we can have a complete image of how a player performs, or how a bowler bowls, or how a player hits the ball. In that way, Rishabh Pant is very unpredictable. So it is a different thing. But yeah, going over not just about cricket, right? A lot of Gen Zs together have been analyzing F1 in this era, and Formula One is growing throughout like the 2050 or 60 years that has been going on. More than that, it started in the like 1950s. But have you ever imagined, like, we all talk about the car. Okay, Mercedes is the fastest, Red Bull is the fastest, Max Verstappen is always the fastest. But do you realize how he knows everything, or how he knows how to tackle each corner, or how he can predict the next, let's say, a pit stop, or the team that goes along? It's not always the driver, it's not always the car, but it's the analytics that goes into the picture. Each car is implemented with dozens and dozens of sensors that track each and every aspect of the vehicle itself. And I'll just tell you, around 1.1 million sensors reading are streamed into the pit wall every lap. So you can imagine, let's say, a 52 lap race, you will go around 60 or 50 million plus metrics that have been analyzed, and a series of engineers are analyzing it each on the step. Why this is important: a driver is going to be intrigued on just driving the car, getting more overtakes, but the team is helping him to manage his tires, manage how he is using the battery throughout the lap, how he can preserve his battery for the next overtake, or the next overtake that has been predicted by the AI, by the metrics that the car has gotten. So let's say Hamilton is leading, Max is behind him. How can Max's team potentially know when Max will catch up? Every lap, if Max starts to preserve his tires and gain some advantage, let's say over a second, he will catch Hamilton in, let's say, next 3 to 5 laps that have been going on. And that's how in the back end all of this data is synchronized. They are using AI to pitch all of that data, merge it, make it in a format that is more visualized, and that is easier to understand to the engineer, and he can then provide insights to Max to, okay, you can have that battery preserved till that lap, and you can then go ahead of Hamilton, and that's how you win a race. There are multiple different scenarios you can find online that demonstrate the actual sheer will of a team that has been determined to win. One of that is Mercedes, Red Bull. Each team analyze data in certain ways, or they have their edge onto it. So tire degradation or undercut and overcut, I'm hoping a lot of Gen Z's already do know this, but there is this stream of undercut and overcut in the F1 sport, where because of the data you can analyze if they want to pit or if they don't want to pit. If they pit early, maybe they can get ahead, or maybe they can sneak in one pit stop, but that's just against the sport. Regarding braking and throttle as well, as I said, a lot of telemetry data is given back to the teams to analyze how a particular, let's say, Max is braking in certain corners. He is known to be one of the late breakers, just like Daniel Ricciardo and some of the other formats. Race simulators help a lot in these cases because they are a merger of AI analytics, that is with data, and AI that helps to have a ghost, let's say, of certain driver who you can race against. So now the question always comes up is that how can data matter more than the driver? A driver is just going to drive, but with good insights he can get you the certain results that you obviously need. Going over, we have seen the craze about FIFA. The currently ongoing FIFA World Cup is like in talk of the town. And have you just like, if you think about it, uh, a lot of these legends, they might retire soon, but the new generation, how can you find the next Messi, and how can AI find the next Messi before scouts do? A lot of regional matches, how a lot of the domestic matches that have been played, they have these newer talents that can potentially lead their country to the FIFA World Cup. Just to make the picture clear, a lot of variables that like these footballers wear, let's say a whoop band, you might know, or different motion sensing tech that they are using. A lot of this data can be fed to a particular model or the AI analytical engine, so to analyze how a person performs, how a player performs throughout his match, throughout his journey from the regional leagues to the topmost leagues. And why we say this is because football is completely based on the team that they're playing, completely positioned where how a person or how a player actually performs. So if I am a scout, or any one of you guys are potentially scouting a player, and AI can tell you a complete historical data of how he plays, where he plays, and what is his most dominant form. Just to have a picture, uh, in a frequency of about a minute, each player is being tracked around a frequency of 25 hertz, that is around, let's say, thousands of metrics per second are being calculated throughout his like throughout a minute or throughout a second. This is a big thing. Why? Because you can expect potentially how he makes the game work, how he actually progresses the ball towards the goal, and how we can predict when the next goal is going to happen, how the game is going to turn out to be. So the pass metrics to the different how the player insights work, what is his dominant foot, how he like shoots the ball, everything can be tracked by using data analytics. And turning all of that into a merged data about the player statistics can be done by let's say AI. uh, Now, regarding the pitch layout as well, where a player plays, what is his dominant position, is also by using GPS and getting all of that data. Also, we can have proper substitutions throughout the game, because let's say 90-minute game, not all the players play complete 90 minutes, but you can change the complete game by substituting a particular player because of his insights or because of how he has played before. A team manager can take that call really, really well. Handing over now to how actually this comes into picture, how the complete AI piece comes into picture. I'll just hand it over to Swapnil Vaidya, who is our solution lead, and he will go on about what everything is. So yeah, over to you, Swapnil.
Thank you so much, Vedant. Hi guys, Swapnil here. I think the introduction has already been given by Vedant and Monica previously. So a warm welcome to all of you, and thank you so much for showing up on the breezy Saturday morning. Right, it's difficult for anyone. I mean, working for throughout the week and then again showing up for such webinars on the weekends. So thank you so much. I hope the session is interesting enough so far. Vedant has already told you about how all of these sports are correlated with the data in the backend, right? These days, a lot of the decision making is happening based on how the historical data has been for each player and for each teams, which ground they play on, specifically for Formula One, right? How the what the track temperature would be, what would be the strategy that I need to use to make sure that I come up as a winner, right? All these questions are specifically for all the teams in the back end, right? What is the strongest team combination that I can go ahead and put forward based on the opponents that I have? Just a second. Yeah, sure. So this all these questions are really backed by data in the backend, and how can we utilize this to make sure that we have insightful analysis, and then take those decisions. Obviously, at times, gut feelings by specific coach or captain can matter, and they may win the game as well. So it's not always that data is always right, but it gives you enough insights or enough data points to make the decisions. And what we have seen so far, right, specifically for cricket, Rohit Sharma is someone who really works along with the data analyst team and make sure that the team combination that they're putting forward, based on the opposition or based on the ground, they would pick some of the players who has performed brilliantly against those specific set of players. With Dhoni, it was more of a gut feeling based decisions. But again, at times it was backed by how many, like what kind of players are in the opposition team. So let's say there are a lot of left-handers who are playing. Then I might think of bringing an off spinner who would be quite efficient on that specific day, right? If there is enough turn for that bowler, right? So all of these sports, and it is not just limited to cricket, football, or Formula One. It again gets extended to uh, play. I mean, let's say basketball that we talk about, right? Or even other Olympic sports as well. Maybe table tennis, again badminton, and all other sports as well. So what I want you to understand specifically throughout this seminar is, how do we generate the data, how do we cleanse it, and at the same time how do we process the data to make sure that we have enough data points using which we can take those certain actions. So for all these sports that we are talking, right, for cricket, football, or Formula One, we capture data in different formats. And this slide and in the next slide, I'll talk about what is the data point that we gather. For cricket, every ball that we bowl is an event. So a player might take a single run, maybe couple. It can be a four or it can be a six, and that's an event. So the data that we capture is, what is the ground, what is the team that the player is playing for, who the player is, what is the opposition, what is the number of runs that have been scored on that particular delivery. And again, all of these things matter and then get fed into the entire database which is there in the backend, and that becomes part of an historic event for you to analyze in the upcoming. So till that time, what happens is you have to, let's say, predict in certain scenario. Vedanta, if you can go to previous slide. Hello. Yeah. So for cricket as well, right? What we do is, we track all of these insights, even for football, right? The things that would matter is, what is the team combination that we are playing. Again, what is, so whether it's 4-3-3, whether it's 4-3-2-1. Again, at times you may play three defenders, four midfielders, and three frontline players, right, who are attackers, and then a goalkeeper. How the the entire tracking would be how the pressing is happening, what is the positions for each player, and how the passes are happening. Similarly for Formula One, as Vedant previously mentioned, right, over a 52 or 70 laps race, we might collect more than 50 million data points, and they would be across different sensors which are placed on a car and on a driver. It would be right from like monitoring the heart rate of the driver to the tire temperature of that particular car on the specific lap as well. Once we collect all this data, we find a suitable database where it can be stored. Again, for every use case, the data set may be different. You can just store it in a structured manner, or we can just pass it as a packet, and different data points can be stored in different data sets as well. Once we have enough data, we can run insights. So I will talk about how we run machine learning algorithms on this data, and even AI in certain scenarios to either predict, make decisions in the future event. Yes. So again, the point here is to say that the best team aren't the strongest; they are the ones who learn fast from the data. So specifically for all these sports and the way the sports are moving today, right, this data analysis item becomes much critical. And just to tell you, all of these teams that we talk about today, right, this team specifically has a team of data analytics which is working in the backend. Even in IPL, they will be having 2 or 3 people specifically from data analyst team who are traveling with the team, which is being supported by a certain organization or an entire army in the backend. Let's say 10 or 15 people who are continuously processing the data and providing insights. What are important actions or critical actions that we can take for the next match, or if you need to help a specific player, right, what his strategy should be for that particular game. Then we can move to next slide. Yeah. So particularly for these three sports, right, what I want you to understand is it's not just for sports, but even for other use cases which are which may be that you're working, or you would work in the future, is what is the data that you are collecting, and then what is the action that you need to take. I think between these two you can just define the entire workflow. It will always be about how do I process the data, then where do I store it, so where do I store it, how do I process it, and then how do I show it. Either you need to show it in certain formats, dashboards, or you just need to just query the data and then get the quick answers from the backend. uh, so in this particular webinar, right, we are taking sports as a reference because you have certain correlation with either of these sports. Once you understand this in some playful manner, right, you will be able to apply it in your regular use cases as well. So for cricket, football, and Formula One, as I said previously, right, we are taking data across different channels. Specifically for cricket, how do we set the field? What is the scoring zone map? So you see commentators speaking a lot about offside, onside, then third man. Let's say Surya Kumar Yadav or AB de Villiers being 360 players. So they do target all the areas of the stadium. Once you understand this particular format for any of the players, right, the decision that opposition captain can take is where do I need to place the fielders for that particular player, right? What is his favorite area to score? For Surya Kumar Yadav, it's through the back end, right? In the third man region where he scores most of his runs. So you can define the strategy or have certain players placed in that field so he can't score heavily in those regions. The matchup matrix, which bowler or which batsman, right, works against a specific player. So let's say Bhuvneshwar Kumar, for that matter, maybe against Aaron Finch is a very effective match. So whenever he comes into the batting, the opposition captain can make sure that um, the Bhuvneshwar Kumar is bowling to that particular player, and as much as he can till the time we get the wicket. Again, all of this is backed by data. You have prehistoric data that how many balls have been bowled by a particular bowler to that batsman, and what is the average, how many runs he has scored, and how many times he has gotten out. And it can also be what pattern the player has gotten out, right, so he can stick to his plans and maybe execute it in the run. Win probability, what is the date that death over planning that he can go they can do. Again, for football, the expected goal shot max, so you can, like, how the build up has happened in the previous matches, You can decide the strengths and weaknesses of each of these players, and you can also predict the expected goals that can be scored in the match based on the prehistoric data. I think specifically for football, we have the demo which will be carried out by Vivek, and you can see it during the end of this session. Again, pressing, you can also decide when to press, when to seat deep at particular moment when the game gets kind of slowed down, and that is when they should do. You can also define the strategy, let's say the how the defense has been by the opposition team. So coaches can decide the strategy where they need to play, how do they need to pass the balls, whether it's a one-on-one passing using that they can score the goals, or it can be long range passing that they can do. All of these data, again, it uses a lot of GPS camera sensors in the backend. At the same time, player movement is tracked. You might also look at commentators saying, or maybe tweets or match analysts, right, that a player has ran, let's say, 5-6 kilometers for that particular match itself. So that again is counted for the player fatigue and player analysis as well. So that is also important. For Formula One, I think yes, it's also about tire degradation, when to pit, how do we undercut, and everything gets into this picture, right? For Formula One, you have to have strict number of pit stops done for that particular race. It will also be important to understand, right? Because after a point, the speed, because the tire degradation is so much, and the tire gets overheaten, you have to change the tires because they are running at such high speeds. So what is the optimal tire strategy that they can have for the match? Should they start with maybe slow tire and then go for medium and then high degradation? So that is something, the data points will help them. What the teams do is they understand other teams' pattern as well, like how the tire degradation is happening for the particular players, or someone who is on high set of tires, and then if they should go for medium or slower ones. So and again, for telemetry traces, we also help players understand what is the corner speed that they need to carry on particular corners. If the car is built well enough, can they carry the same amount of speed at higher gears, which will help them optimize the overall lap strategy as well. And again, race simulation, again, all the data points that these players collect, right, they have entire simulators in their factories. So they can simulate the entire race and create the strategy before the race. So that's also one important factor that comes, and specifically for Formula One, right? Um AWS is quite associated with the sport, and they help them carry out these entire analysis. If you can see, a lot of IT companies are partners, and they are not just name partners, but they work in the backend a lot with these teams to understand the data that they capture and how they can work on top of it. For example, Gemini, Google specifically, right? They are a title sponsor or a very close partner to McLaren Formula One team. So that team uses a lot of these data points. Work with Google very aggressively to build entire strategies and how they can. So let's say help the teams to use AI across different areas. Yes. Let's move to next slide, Vedant. Yeah. So the way sports analysts work, right? What is the job of sports analysts in this particular area? I will go slightly technical from here onwards. Is to collect the data. You can use different services like, let's say, Kinesis, Kafka, from the sensors, right? So for different sports, it can be the data is because it is coming at such high speeds, right? Specifically for Formula One, or maybe for sports, it you need to understand what format the data is coming in based on the sensors, and how do you push it. So it can be, the streaming engines can be Kinesis or Kafka, or you directly ingest with whatever data storage mechanism that you have in the backend. Where are you storing it? Again, I don't want you to just understand the services, but based on the use cases, these services will change. Not necessary that you have to use Kinesis or Kafka only. If there is a better mechanism based on the data format that you're operating, you can change it. For data store as well, it can be a database, it can be a raw object storage. um, or at times what happens is the data is stored locally, maybe using the hard drives, and then it can be used later. So the sports that you're operating in, or maybe the use case that you have particularly, you can use S3, maybe other object storage or other cloud platform altogether. The other use cases that we had was on the IoT piece, right, where we connect a lot of data from the sensors. So in that particular case, we use Kinesis for data streamings. So the devices itself have 4G SIMs, so they can stream the data at regular intervals, which is captured by which is captured on cloud, maybe, and streamed to the other services or data storage. Let's say something like S3 over Kinesis. So you can define a mechanism where you don't lose data. It is also important the way you architect. You don't lose data. Maybe if you're using queues or something, you have dead letter queues in the backend, um, and you ensure that all the packets are intercepted and the data is stored in the storage. It can also be that you have, let's say, data warehouse and data lake kind of systems in the backend. So the data that you get can be in very compressed format or cheaper format, so your entire strategy makes sense. And then you use certain transformation mechanisms, maybe something like glue or polars or other ETL kind of processors, to transform that data and then store it in the warehouse kind of a system. To analyze the data, you can use different services, maybe something like Athena. You can use maybe Power BI as well to analyze and then visualize it. So again, maybe Tableau is one service that you might have worked on. For visualization, the dashboarding that you may need, right? Just having plain text data may not be sufficient for anyone to analyze, or even for players who do not know how to make sense out of it. To make sense out of all the raw data that you have collected, you'll obviously need to create dashboards, or you need to maybe set up in a database and then have AI engine running on top of it, where you can do plain text queries. It will either fetch the data from the database that you have, creating the queries in the backend, or it can just decide, maybe use RAG sort of a system in the backend as well. I think we'll be covering that in the demo. How do we build this entire engine is, let's say if you're using something like AWS for end-to-end strategy. For storage, you can use S3. For processing, you can use Glue or Spark for ETL. For querying, you can use Athena or QuickSight, and then dashboards can be built using QuickSight. And again, if you want to build something open source, which will be an, let's say, weekend guide of strategy is what we call it. You can use DuckDB for storage. Again, very lightweight, not very heavy. You can host it as a container as well. Support Spark as a format. And then for processing, you can use Polars GPT. The only thing with all of these open source technologies is the management can be heavier. But if you have teams in the backend who can operate with the certain set of technologies or tool sets that you're using, you can obviously go ahead and use the data sets. Not necessary that you build everything on AWS. You can also use maybe Azure or Google, Google Cloud of sort of platforms, and they have their own tools for all of these. You can use mix match as well, where you use certain AWS technologies and then you use some of the open source tool, maybe for ingestion or maybe for storage as well. So yeah, in the next slide, what the three levels of sports intelligence, right? um, Again, based on data that you have collected, what is that you want to do out of it? Um, so it can be a questions to the data sets, what I want to actually retrieve from the entire data that I have collected for specific sports. So maybe you want descriptive learning. This is where we use the entire, let's say, machine learning mechanism in the backend, and AI as well, to describe what has happened in that particular event, right? A match summary kind of a thing, where you might have watched a lot of sports and you see um, commentators or even match analysts telling you where the game has gone wrong for particular team, or where they have won it. Maybe a particular player has played really well, and his strategy may be counter-attacking in those middle overs, playing with strike rate which was more than 200, helped them save the day. Or it can also be a particular bowler has bowled economically really well, which was the reason they were able to defend the target. He may not have picked the wickets, but at the right time when the team wanted to score, he came in, bowled those 3 or 4 crucial overs. So that can be an analysis which the entire system can give you. What it will analyze is the entire scorecards, how the average has been through middle overs to the through the last overs, and how does it work, or maybe compared to last 10 matches that have happened on the same ground. So it will just analyze and provide you the analysis, right? So let's say the team which has batted first scored 220 runs, but the analysis that we have seen so far is 220 is not very defendable target on the ground. But in the particular match, the bowlers have bowled really well, specifically through middle overs, where they have tightened the screws and they have not leaked runs. So that can be the descriptive message which AI will analyze for you and just provide you the analysis for the team who has lost, and they can work on it in the next games as well. The predictive algorithm. So what will happen is, here you will use lot of, okay, in the previous slide you use lot of SQL, Athena queries to extract the data and then present it. The presentation or the descriptive um, messages or the descriptive analysis that you need to create can be through AI as well. And where it uses mix of machine learning and artificial intelligence to provide this entire analysis to you. In the predictive analysis, you just want to ensure that maybe in the next game what will happen is what you want to cover. So what it will do is, based on the previous or historic data that we have, you can use linear regression algorithms or XGBoost and some others, right? Again, you need to understand these ML concepts to maybe cover this, but it will have this entire tree based analysis done for you, where it will give you the what is the winning probability of this particular team, because maybe they have been winning consistently for last 4 or 5 games. The team combination is quite good. All the first 5 6 players are scoring runs, and this is what ML algorithm will understand, the previous form of the team. So the winning probability will take all of these factors into consideration. What is the team combination, who is the leading scorer, whether he's playing in this match or not, what are the results for last 7 or 8 games. So in the XGBoost, what it will do is it will go by all these factors, maybe 7 or 8 uh, categories that you have defined for the winning probability. If everything is beyond certain threshold and is working fine, then it will give the winning probability, which will be on the higher side. What is the expected goals, particularly for football, right? Again, it will analyze the prehistoric data and provide you that input. What is the injury risk? So let's say a player maybe has performed well for last some number of matches, but again, as I said, right, the graph can map how many kilometers he has ran for the previous matches, and after some point there will be a fatigueness that will come. So if the player is not rested enough, it will kind of generate that alert that the player may be injury prone and should um, sit sometime, maybe not play the entire game, should come as a substitute and play 20 30 minutes, so he can have high impact as well. The forecast before the event, it can be in a cricket match, right? The possible forecast that the wicket may fall maybe through the middle overs. Again, the prescriptive is what should we do, the recommended actions. This is where AI can be used, the agents can be used to define the entire strategy. Who should bowl the next over, or which batsman should come to bat next. Yeah, Vedant, we can move to next slide. Again, how a machine learning, how a machine learns a sport. This is entirely through defining the mechanism, right? For you to generate all these analysis, it is important that we understand the data that we are playing with. Machine understands it over the period of time, and this will be through a lot of training that happens in the backend. So as I said, historical data maybe for last 5 10 years, where you are capturing all the data points. For cricket, it can be last 15 16 seasons of IPL, where we have pushed a lot of data. This can be millions and trillions number of events. So it will take a lot of GPUs in the back end. It will take lot of for the machine as well to learn, right? Which algorithm that you need to use, and it can be different algorithms for different data sets as well. So you work, you train these models over the period of time again and again until you find proper predictions happening, and again for different tasks or different predictions that you need to make, or the analysis that you make. um, so that's what happens again for features. Encode the sports, the machine needs to understand the data points that we're talking, right? What is the batsman, who is the bowler, what is the event sounds like. And again for training you can use SageMaker, which is an AWS platform which works end to end from training till the point inferencing happens. You can use different regression or complex techniques in the backend. It can be XGBoost, it can be light GBM, and it can be few others as well. Also, you need to ensure that throughout this mechanism, whenever you are training the machine learning, or when you are creating the machine learning pipeline, the leakages don't happen. If the leakages happens, or if the data is missed, how do you pass it back to the machine? Do you have feedback loop as well created for this entire machine learning cycle that we are creating? Where do you deploy it? What do you use as an inference endpoint? What GPUs do you use? What let's say architecture that you're using at the hardware level as well to train these models over the period of time. And even for the feedback loop, right? Are you capturing enough data points to understand whether the predictions which have been created, or maybe let's say the analysis that has been created, whether it's correct or not? Once you pass it back to the machine keeps learning. And as and when machine or your AI keeps learning from the outcomes that it has created, and when you label the data with um, let's say satisfaction of that output, maybe some satisfaction score, it will understand how does it need to predict in the next cycle. So that's really important. So again, we talked about how a machine learns sports, and again the different models that it will use, right? Specifically for machine learning, it can be XGBoost, light GBM, random forest. As I talk about all of these models, right, and everything, the models get complex, but the accuracy increases over as and when we move it. So XGBoost is slightly lower, may consume less compute. Light GPU may consume more, but it will give you more accurate outputs. And again, it's not that because light GPM gives you accurate outputs, you should just go ahead with it. XGBoost for certain use cases may work just fine. And again, you need to understand what is the predictions that you're doing, what is the data that you're dealing with, what is the correlation between the data from one event to the other, and how the outputs have been over the period of time. Based on that, you use maybe sample of data to predict using all these different models, and then decide which model is correct for you. And all of these models again are part of SageMaker. If you're using AWS, all of these are readily available. You can just go ahead and use it. I think one of the example can be given by Vivek in the next few slides. Again, so neural nets and maybe just understanding model weights and other. So for AI to understand and AI to predict, right, the models or the correlation can be different. It's not as plain as machine learning. Machine learning could be it's very straightforward in a way that you help with all the data points that you have, and it creates its own analysis. With artificial intelligence, it understands the weights, the transform architecture and everything, and the correlation between the data. And it creates its own transformer based, weight based, I mean the entire neural network in the backend, right, which it uses to predict. And because it has also learned not just sport, um, but let's say an understanding of a language in general, right, and also some other scenarios, it will understand few other things as well. When you're creating a machine learning, you're just helping that machine understand what sport is and what is the outcome that you want, whether you want analysis, whether you want prediction. But with AI, the way you want to put it across from the, let's say, whatever machine learning output that you have created, if you want to present it in a plain text format, be more of analysis or documentation, and create an entire report summary of the match, for a commentator to speak, it will do a much better job. But again, the data churning and the output can be done very well using machine learning itself. Next slide. Yeah, turning numbers into narrative. This is where mix of your machine learning and AI will be used, right? So you have all the frontier models which are available, maybe as part of Bedrock, or you just want to use the APIs which are available, right? It can be Anthropic Claude, it can be GPT-4o, Llama 3, Mistral, Grok, NVIDIA, you name it, right? So let's say your question to the model, because in a normal scenario, if you want to fetch data from ML, it can be a query and you get that data. But let's say you want a plain text narrative, because if a player is directly using that platform which you have created of all the past data sets that you have given it, um, a normal person will not be able to use ML very efficiently unless it has just set of dashboards that you have created. But what you want to do here is, maybe just ask questions to the model or the entire system that you have created, which is mix of ML and AI. Simple questions can be, what is the analysis of last previous match? Why the certain bowler was effective in that particular match? Or it can be just creating a entire platform for the team itself, where they don't need to get hold of or chase data analyst all the time to understand what has been the analysis like. So we can provide a platform where we integrate it with AI. So let's say maybe question can simply be, why did we lose despite scoring 200 runs in the T20 game? This can be a query from the coach, before the analyst coming, analyzing everything, and then putting up that entire, maybe a presentation. Uh, the AI will scrape the data for you. It will create its own queries, maybe get the data from machine learning, and then, because as I said, right, the general intelligence is there of the language, it will be able to provide that entire analysis. The queries to the backend can be, what is the, for the team who was chasing, right, what was, how many wickets fell, which player scored maximum runs, what is the average or the strike rate that he scored runs with in the middle overs when the game was maybe tight, where the boundaries were not scored but they rotated strike. So that can be an analysis which will be put across by AI, so the coach can understand in a simple text manner, and he can ask as many questions as he want. In a previous scenario, if the analyst is coming, it will just be his own intelligence which he is putting to create the summary. But in this scenario, because you are asking as many questions as you want, and AI is, just say, let's say, churning the numbers from the ML and then putting it across as dashboards and in a simple narrative, so it becomes very easy for you to understand as well. Yes, we can move to next slide. Again, um, when these plain text questions are asked to AI, right, uh, the AI has to be smart enough, the router itself, or the model that we are talking about, right? Maybe you're using Claude, you're using GPT. You can use models with lesser intelligence as well. So your token costs are not high, you are still optimized. But over the period of time, you train it enough and you give it enough intelligence, because in this case, the queries or the inferencing is not about how intelligent the model is, but how intelligently the model can get the data from the different sets it has, and then present it in some manner. So maybe you start with a frontier model, maybe run it for a few days, get the understanding, and then replace it, pass that intelligence, okay, use it as a training to the model with which is less costlier. So not necessary you go with GPT. Maybe for Claude you can still stick to Haiku, because it needs some understanding of the natural language, and it just need to represent data which was provided by machine learning, and it needs to have enough intelligence to draft queries on its own to the ML model and understand the graphs that may be provided by the machine learning algorithms, and has to be smart enough to understand where the queries can be passed through the database, maybe through MCP or to the RAG that we have built in the backend. If the model is capable of just handling these 3 4 things in a smart way, you won't need something like maybe Fable 5 or Opus 4.8 or maybe GPT 5.6, which has come. The motive here is, could we get the same level of output, but at the same time not burn too many tokens? And this is the question for all the AI architectures that we are doing today. Is, do you actually need the model which costs, let's say, $15 or $30 or $40 for every million token? And that can be a huge amount of burn that you can save if you build efficient RAG, if you build the model intelligent enough to ask or maybe to query right set of data sets in the backend and just present it in a smart way. So if these are, let's say, repetitive tasks that are happening over the period of time, you can just have a small model hosted at your own data center, or you can just have maybe model with less intelligence or less parameters, something like Haiku, or maybe use Gemini, maybe Gemini 3. Not necessarily you need Pro, or you don't need model to generate images in this scenario. Again, particularly for this slide, router will classify the questions. It will understand, let's say the question can be as simple as how many runs have been scored at Chepo, the Chennai Stadium, this season. It is a simple SQL query that you can build to understand in this season. So the query can be, let's say, select matches at Chepauk, which has happened. What is the first inning score and what is the second inning score? And it will just be a tally that it will be presented, and then it will present it in a normal text format. You don't need RAG for this. Let's say the question is more about what is the strategy, what is the prediction for tomorrow's game. Then it will trigger the ML algorithm in the backend, or it will just query the vector database and understand the patterns, right? What is our plan should be for Travis said. So let's say you need grounded answers and you need citations. It will, so let's say if you have the scouting or all the analysis that you have built over the past few matches, so it's not just data but analysis of those games and what is the strategy that could have worked or should have worked, maybe built in the RAG entirely. So the question can be to the RAG, and based on the patterns that it understands, right, it will create an entire strategy, which will again be highlighted or maybe studied by the coach and the captain. They may try it and then they give the feedback, and your system again builds intelligently over the period of time. Again, a very raw LLM, if you build it, as I said previously, right, would fail both. It will give you stale answers and it will not be grounded. So it's also important the entire system that you build, the LLM flow that you build, is backed by very good RAG system in the backend, which understands the patterns and the all the important facets of the game, and it also is able to route that query um, to particular, let's say, the MCP or the database that you're using for this, or do I need to use RAG, or do I need to trigger the ML algorithm, fetch the data, or maybe use mix of all. So it can be spinning up agents in the backend that LLM needs to do. So again, what we say is, I mean, whenever we build this workflows, right, it is very important for us to um, maybe do a lot of prompt engineering, a lot of analysis with the data labeling, understand the data in the initial stages itself, ensure that we retain a lot of connections, patterns, or even correlations between these data points. At the same time, the LLM itself asks right questions. Again, building a grounded co-pilot. So when we say build RAG, how do we make sure that we build efficient RAG systems? Particularly for this use case, um, because we need to do some analysis, it is important that we have historical data from the coaches, from the players, of notes and reports. So a match that happened, their analysis which is provided by coaches, and how do you store it in a RAG? How do you chunk that data? How do you embed it and store it in a vector database? Your vector database can be anything. It can be open search, it can be Chroma, it can be Pinecone, all of these database in the backend, right? But it is important that you understand which database that you need to use, whether it's in a graphical format, maybe a GraphDB that you want to use, or some other databases, right? How heavy that data set is. Based on that, you can take that decision as well. Particularly for the nodes that have been created, right? Ensure that, because within those reports as well, there will be different analysis pointers which are happening for the main team and for the opposition team, which is again linked to that match, and maybe for prehistoric matches as well. So if you're talking about a particular player, we are not just talking about that match, we are also talking how he's carrying that form from the series of events. So how do you chunk it, how do you embed, and how do you maintain that correlation specifically for this scenario, becomes really important. uh, Again, whenever you query into the RAG, right, based on the questions that you have asked, whether you need to build agentic RAG, because there would be subsequent pull from the RAG that needs to happen, and you because you need a particular set of context, right? The chat that has happened, that anyways will be there, but the reason that you need RAG is you don't want it to analyze, let's say, 1,000 matches that happened, and 1,000 nodes of those particular matches are available. So you don't want to just pull all the 1,000 nodes and your AI model to read through and analyze all of these. It can be, the processing becomes slow. It will not be able to maintain that level of context, so that the top key context, right, becomes very important. Based on the query that you have asked, it will try to, based on that query, right, it will try to match and just pick up, let's say, the top key context from the RAG itself, right? That is where retrieval will happen, and re-ranking, like what are the most correlating items for that particular prompt or the query that you have created. Once that is there, you pass both the retrieval from the RAG, let's say the ML that is anyways, or the reports that it has, and the within the chat itself, right? If there is any context that the model is carrying, based on this, it will try to give you a proper reasoning and a proper grounded answer. Otherwise, if you just retrieve everything that you have from the RAG, the answers will be vague, will not be very precise. So it's important you give right set of context to the model, which is very close to the prompt that they have asked. So if I'm asking about, let's say, Shubman Gill, right, the model should not retrieve about Virat Kohli and how he has played in the past 10 matches. It will be unnecessary context to the model. It will lose its computing power for unnecessary tasks. At the same time, the retrieval which we need will not be there. So the correlation will is something that it will miss out on. And again, based on the retrievals and re-ranking, right? And this is usually happens on all the prompts and the standard RAG that we build. The answers will be very cited and grounded if we build the RAG to be more grounded. Again, when we are building this entire layer, right, how do we build it? Is, let's say, if you're building on AWS, the embeddings can be stored in Titan, Cohere. I mean, that's something that you use for generating embeddings, and it can be stored in vector. But we use a lot of other open source models as well. So the workflow can be, agentic workflow can be created maybe using LangGraph, LangChain, or models you use maybe Claude and others. So the option or the choice is yours how you want to build this entire workflow. For RAG, as I said, you can use different databases as well. Agents plan and use tools. So if you are building agentic AI, that's again, so just having RAG in place, maybe the question can be, can we build agentic RAG? And because agents work on its own, it will not just be analysis and answers. It will be based on certain event that has happened. Can I just trigger the agents to do its own work? So let's say after the match is over, just create me a plan or entire summary of the match. Can be an activity which is provided to the agent. You need less human interventions. Maybe human in the loop, again, that is recommended to have, but it's not. The agents will have access to certain systems as well. So the basic differentiator between your normal generative AI kind of stuff and agents is, agents are able to execute the tasks and not just work on the prompts that you have given. So maybe it can be a time based events when it will perceive reasoning, and the entire workflow that I talked about can happen entirely. And if you need to have certain loops or maybe approvals in the backend, it will be approved, or you can just so during the um, because even for AI to come up with the reports, it will take time, right? Once the first inning has happened, or maybe first 10 hours has happened, you can just make sure that the agents work in the backend and give you those analysis and reports. Maybe insert in a normal scenario, it can be if certain actions are performed by a human or maybe by a machine, you can just trigger the event. A simple use case that I usually take is maybe KYC, right? If you are within your application as well, if the KYC is happening, what you can do is, for the banking application specifically, user will upload all of his documents, maybe Aadhaar, PAN card. The agents can trigger and start verifying the document, matching it with the DigiLocker which is there in the backend, calling those APIs, making sure that and create the score. What is the match like? Let's say 60-70%, and you need matching on top of that, right? Based on the outputs that you have, whether it's crossing checks for all the items. So whether the address is verified, PAN card is verified, PAN card number is matching to what is there in your system, and again the photo matches with what is there in DigiLocker or maybe on the cards. So all agents will perform all these tasks parallel in the backend, so you don't need to go and check manually. So that is where agents can be used. Again, the entire systems can be built with agent core, which allows you to connect with other open source system in the backend, or use LangGraph, use Crew, and you can also build Oriole guardrails in the on Bedrock, or maybe on your own as well, right? Where you need to ensure that the data masking happens, personal data is not shared to the AI. A reference architecture. I think this is quick, 2 or 3 slides before I close and hand it over to Vivek. Um, the sources, again, in the particular AI architecture that we are building for sports, right? The sources can be all the specifically for football, it will be cameras who are tracking the movements. If the players are fitted with GPS tracker, so we get the entire movement of that player, what is the heart rate like, the breathing pattern, and how frequently they are running. So you analyze that and then make prediction in the later stages. Telemetry specifically for F1, we have a lot of data lot of data collectors, sensors running on the cars itself to understand the wind blows, how the car travels to specific corners, what is the speed that each of these tires are carrying, what is the temperature for each of these tires, what is the gear that car in on particular position on a track. So everything specifically for cricket, every ball is an event. As I said, you track all the different 15-20 parameters for each of the ball that is bowled, including bowler, batsman, the speed of the ball, the bat speed, where it landed, who caught it, who fielded, how many runs that have been scored, and everything. Again, this is ingested, as we saw initially, right? This is ingested to a data storage in the backend, where it uses streaming patterns in the backend, and then you store it somewhere. For transformation, you use Glue, you use other ETL tools which are available. For the training, you use SageMaker or your own ML models that you have created, or the platforms. The beauty with SageMaker is you can create end-to-end pipelines. You can it has own library of models which you can import and then start using it right away. Um, the inferencing can also happen on SageMaker. Training can also happen where it spins the required instances, and for serverless duration. So you are not um, utilizing one instance which is sitting idle and you are paying for it. So if you're working at a small scale or even at a larger scale, SageMaker becomes very effective. And again, there are other options available as open source as well. Again, if you're building RAG for AI specifically, you can use Vedant, we can stick to previously. Yeah, use open source or use any vector DB that you want to use, and then Bedrock knowledge base, maybe for RAG and guardrails that you want to define. And then entire orchestration, right? The LangGraph, LangChain is something that you want to use, or agent core, and then you serve the outputs of this entire workflow to the coaching team or to the broadcast team, and you keep seeing those flashes. whenever you see sports, right? um, for Formula 1, you see like which lap in the next 3 laps this car will pass the particular car, or this will become the race leader unless any incident happens, and all of these predictions are backed by data in the backend. The reason for us to carry out this particular workshop is you take a topic which you're already interested in, and then understands how ML and AI work in the backend, um, for your particular or favorite sports, right? uh, to give you the data points or reasoning that you have for why such particular event has happened in that particular sport. I hope it was useful. I'll hand over to Vivek to carry out the small demo that we have, and it will again, whatever things that I have covered or even Vedant has covered, he will be able to demonstrate you using the demo. Over to you, Vivek.
Uh, Thank you, Swapnil. Thank you, Swapnil, for the wonderful briefing. Thank you, Vedant, for the wonderful overview. We have seen like how AI is gone through AI sports, and how we can leverage all the services and the functionalities, like training a model, inferencing an particular model, creating a live endpoint using SageMaker, using Bedrock, how we can prepare a data set using different services in AWS. So we have gone through all this. So what's up for today? So today I will walk you through a live demo of a particular data set, which has been taken from Kaggle, a football match data. So the this is a payoff. Everything from the talk uh, running live, and it's genuinely hard problem, which I will be honest about six, only six countries have ever won a World Cup. So we are learning from very few example. I am reporting the accuracy straight, not overselling it. The data is team level, one row per team per tournament. We'll walking through the entire demo, like example match predictor, like who will win, like Argentina or France, who leads the FIFA World Cup, uh, and etc. So I will walk you through the demo, like how we can leverage AI services, machine learning algorithms, and machine data, right data to predict the right amount in this analytical world using ML. So I hope my screen is visible. So 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 I prepared some of the data. Then after preparation of the particular data for the team level, so the data is entirely team level. So entire data is of World Cup for four nested stage, like quarterfinals, semifinals, finalist, winner. One classifier for the stage. Behind the scenes I have used gradient boosting classifier algorithm. uh, Gradient boosting trees, like same family as XGBoost, but built on cyclic learn. So this entire model can be deployed in the entire AWS ecosystem, in the SageMaker service, where we can add this data into a particular S3 bucket and can be integrated with any of the Jupyter Lab. The code can be integrated into Jupyter Lab, where you will get an canvas presented, so that there is an entire life cycle of the data preparation step, model running, and choosing a right type of instances, like a MLX large, or based on your inference level or the model or data training level. You can choose a particular, then you can create an inference endpoint in the SageMaker. But for this demo, I will showcase like what type of model I have created and what are the endpoint and how we can leverage the entire data set. So as I mentioned, the data is team level, so one row per team. So what is this is, over the decade, so we convert everything within the tournament percentiles, right? The model sees relative strength, non-era floated raw data. You will see two things: a match predictor picks any two team get instance head to head odds and title predictor. We simulate full 48 teams 2026 bracket thousands of times. Okay. uh, so how we can like create an entire production shape using SageMaker, a live endpoint. So as I mentioned, I will be using the XGBoot similar family algorithm. So let's get to the demo. So this is one of the get slash predict slash champion. So I will just try out this API. So once this API is called, as you can see, the entire first before that I will showcase you the entire data set I have used for the training. So this is the data. So for particular API, predict the champion. So France is with a winning probability of 0.22.62, which has a leaderboard, which comes in the top rank of the leaderboard with ranking one. Then comes the Spain. Then comes the other team members like Portugal, Argentina, with their particular ranking and with their particular finalist percentage and ratings for a particular team. Then I will go through a particular team. Like let's assume mm, stats. So let's assume you have a particular favorite team. It's Argentina. So once I execute it based on the historical data of the team, as you can see the entire statistics of the team Argentina. So what continent it belongs to, the World Cup titles, the World Cup participating, and the time reach finalists and semi-finals, how many it got, and from last 4 years, wins, how many wins, how many draws, loses, and goals scored, goals concluded, and what is the FIFA ranking, and etc. The entire details can be seen over of the past few years of the particular team. Could be any team, like it could be Spain also. So this model entirely trained on a particular data set of each particular team. So coming coming to a match prediction. So starting with a simple thing. Starting with a simple thing, let's now predict two favorite head-to-head teams, like win, draw, loses, and most likely score. This is deterministic and same team and same answer. Let's assume we have a home team France. So for our matches API, let's assume we have a home team France, and the away team is Spain. So if there is a match, head-to-head match between these two teams, so what could be the prediction based on the historical data we have seen so far? So as you can see, uh, it showcases that home France and Spain. So total count, like percentage of home win is some of the other points, and likely win, and it's most likely says that they will be scoring, likely scoring one on one. It could be a draw. So this is how you can predict the two different players. Other API we can call, or the model we can call for prediction is champions. For the entire data set, let's assume like who would be the champion, who would be the not, who will be the top ranking. And behind the scenes I'm using Olama. So I will just stop presenting and share my entire screen. So I have used train data set. So this is the entire train data set of a particular match, like from 2002 to 2022. The entire data set has been there. Then there is a test data set has been created. Then, as I have mentioned, I have used the gradient classic. gradient boosting classifier behind the scenes using cyclic learn. So which will help me to figure out like the World Cup participant, who will be the winner and who will be the not. Then behind the scenes, I have used a fast API for an inferencing point of view to for creating the entire APIs and creating the particular endpoint. So there is a final API. So behind the scene, I have used Olama, so a SLM model to predict into a plain English language to answer the who will be the right winner, who will be the uh, right World Cup winner in a particular area. So if you ask like who will win between the France and Brazil, or you can say other way around, like mm, so if you try out slash explain API, which will be like home will be France and away will be Spain. So behind the scene, the data is there, which the model has been trained, and it will use the Llama 3 model to for a proper explanation. So this is all the numeric data, but most likely we want a readable format of data or proper explanation. So France is currently the favorite to win with 40% rate compared to Spain is 35. That indicates that a team has more success against the opponent so far. As a result, they are considered the most likely outcomes of the match. So behind the scenes, the source is Olama Llama 3.2 I am using. Based on the data, the model has been trained. Then there is an other API. So like let's assume who will win the World Cup 2026. So let's ask the model. So who will win the 2026 World Cup, right? So let's see how it predicts the model using Olama as well. So this was my question. So who will win the 2026 World Cup? So no team. Who wins? Tournament favorites. So France, Spain, and this. So France is currently the top favorite win of the 2026 World Cup with 23 chance of victory. So this is the small demo that showcase that uh, how we can use the entire historical data and predict in a particular model uh, and showcase the right time of data. So in a minute. So what you just watched wasn't just football specific. It's a pattern. Uh, it works for any sports. Sorry, in a minute. Yeah. Okay, so coming, it's a pattern. So as I mentioned, it works for any sports. This slide shows the same idea in cricket and analytics that answer two kinds of questions down to different paths. A statistical path for structured question, the best that over which predicts based on the numerical data, and which goes through vector stored local LLM from the grounded answers, just like explain calls. So behind the scenes, it is like entirely predicting based on the numbers, statistics, and converting into a plain English text, so that we can have the AI be integrated in the sports analytical world, which will give the whole ransom of new brain ideas, which helps the team to predict the winners by using right amount of statistical data in the entire flow. So that was the whole demo which we created for this presentation. So if you have any doubt regarding this, feel free to ask.
Thank you, all the speakers and all the attendees, for attending this insightful session. And and an applause for our speakers for keeping this session alive with their exciting energy and also uh, purposeful insights. We are open to welcome questions from the audience right now. We can answer them at the same moment. And in the meantime, you can also scan the QR code given on the screen to share your feedback of the session. We'll wait a couple of minutes more for the questions and then we can dismiss the session. Okay, L Manna is asking, will we get code for this session? Code for this project, sorry. Hello, any of the speakers would like to let him know?
Vivek, you want to answer that question, or should I?
Yeah, yeah. So so she wants a code, like demo code.
Yes.
Yeah, yeah, can be shared.
She's
Just
also sorry, yeah, Vivek.
yeah, yeah, yeah. Continue. What is the question?
They're also asking, and what if we need to collaborate on similar project?
Mm, it
Let
depends.
me
Like it
answer that.
depends.
I think if you have any projects where you need maybe some guidance or feedback, happy to provide that. But I think the demo that Vivek showed was particularly created for this project, and it's more like a training demo just for you to understand the concepts at a larger scale. When you actually work with bigger organizations, or maybe specifically with sports team, the data sets would be very huge, and you would have different teams working across different tool sets. So I think if you have a use case where you want us to be involved as an organization, happy to do that. But on a small scale projects, I would highly recommend you to maybe go through the training courses, or you can just connect with us on LinkedIn if you need any guidance or any feedback on the existing projects that you are working on. We can definitely extend our feedback, or maybe any way that we can help. Hope that answers the.
We have 1.5 minutes more. Is there anything else you would like to ask specifically for the attendees?
Also, guys, if you could just quickly scan the QR code and provide the feedback, it would really help us improve the forthcoming sessions. And also do watch out for coming sessions as well. We would be covering different topics, so make sure that you register for those. Specifically for these sessions, we wanted it to be in person within our office premises, but due to certain reasons we weren't able to. So in the maybe monthly sessions that we plan, we will try to see if we can meet face to face and have more engaging sessions. Swapnil, if you can check if you have feedback from everyone. If not, I mean, just make sure that we get
Yes.
it.
Okay.
So I guess that's all the questions that we have from the audience. And thank you so much for joining on a Saturday morning. It means a lot and it shows your enthusiasm towards the technology. Thank you all. Have a lovely weekend. And thank you, speakers. We are ready to dismiss the session now. Thank you all.